Now we'll start with the property of system. Okay, so once again, memoryless system already I covered yesterday. We know that y of n is equal to convolution of x of n with h of n or h of n with x of n, which I expanded as x of k into h of n minus k for all values of k. That is h of minus 1 into x of n plus 1 plus h of 0 into x of n plus so on and so forth. So once I keep expanding this one, okay, plus so on and so forth. What happens here is system to be memoryless. It should not have any terms of x of n plus 1 or x of n minus 1 or any other terms, okay, in this one. So these terms are not allowed. So that will happen only when this results in h of 0 and x of n. That is nothing but h of k is equal to c into delta of k. So delta of k exists only when k is equal to 0. Therefore, for continuous time systems, h of tau is equal to 0 when tau is not equal to 0, or h of tau is equal to c into delta of tau. For discrete time systems, h of k is equal to c into delta of k, which will give the value only when k is equal to 0. Otherwise, let not have any value, therefore system becomes memoryless. Similarly, now a causal system. A system is said to be causal only when the present output depends on present values of the input or past values of the input. Once again, let us take y of n equal to h of n convolved with x of n, that is equal to h of k into x of n minus k. Once again, I'll expand it, h of minus 1 into x of n plus 1, so on and so forth on the left hand side, plus h of 0 into x of n plus h of 1 into x of n minus 1 plus so on and so forth on the right hand side. So no future samples are allowed. So that is x of n plus 1, x of n plus 2, so on up to x of n plus k. All these samples are not allowed if you have to say that this system is causal. So that I should eliminate all these samples. So what is the meaning? H of k is equal to 0 when k is less than 0. That is h of minus 1, h of minus 2, h of minus 3. All these things should become 0 only when you say that system is causal. That's what is the conclusion. H of k is equal to 0 for k is less than 0. Similarly, for continuous time systems, h of tau is equal to 0 when tau is less than 0. So anything after 0 is allowed. 0, 1, 2, 3, everything is allowed. But below 0, none of the samples are allowed. That is called as a causal system. Any doubt? Are you able to follow? Any doubt?
No, sir.
Now, let us look into the stable system. A system is said to be BIBO stable. BIBO means bounded input, bounded output. What is the meaning? If the as long as the input is bounded, output will also become bounded. So that is the meaning says that if for a bounded input, the system produces a bounded output. For a discrete time system, then x of n is strictly less than mx, which is strictly less than infinity. The bounded output is given by y of n is less than my less than infinity. Let us consider y of n is equal to h of n convolved with x of n, that is h of k into x of n minus k. What we told here, taking the modulus on both sides, this will become modulus of a into b. Remember, modulus of a into b, I'll take modulus separately for h of k and modulus separately for x of n minus k. Strictly it becomes less than or equal to, are shown only equal to. Okay, modulus of a is equal to modulus of b into c I have written. So which is equal to or less than or equal to. Both of them are whole good. At this moment, we'll assume that they are equal. Here we have assumed that x of n minus k input is strictly bounded. So input doesn't go out of bounded out of the bound. So when y of n is should be bounded, you must know that h of k should be less than infinity. So if h of k becomes infinity, even though it is x of n is bounded, output will become infinity. So Output can become infinity, either h of k is infinity or x of n minus k is infinity. We are very sure that x of n minus k is not infinity. Therefore, what is the another probability? H of k. So as long as h of k is less than infinity, the system will get bounded. So the impulse response of the system is absolutely summable. Why the term absolutely is, we are taking absolute value, that is modulus value, all the values are positive. Even though there are negative values in h of k, they are converted into positive value by absolute term. If you add all of them, it should become less than infinity. So as long as this impulse response is absolutely summable, your y of n, the system is stable. So I written it for discrete time systems. For CTS, what happens? Summation gets replaced by integration. H of k replaced by h of tau into d tau, that is less than infinity. So is the one line that you have to understand. Impulse response of a system should be absolutely summable to say that a system is stable. Now we'll go for invertible systems. What is invertible system? Given x of t and you have a system with a response h of t. What is the output y of t? Y of t equal to h of t convolved with x of t. So I will design one more system with the impulse response h inverse of t, so that when convolved with y of t will once again give me x of t. So what is the meaning of invertible system? So if the input of the system can be recovered uniquely from the output, so this implies that existence of inverse system. Look at this one. Output of the second system is same as the input to the system. In that circumstances, we say that h of t and h inverse of t are mutual inverses. And remember that you should recover the input uniquely. Okay, x of t means whatever x of t, same x of t you should have, not even a change in sign is allowed. So now let us get what is x of t is equal to, see here, y of t into h inverse of t. Look at the second part. X of t is equal to y of t convolved with h inverse of t. So what is y of t? Y of t is equal to x of t convolved with h of t. So x of t convolved with h of t convolved with h inverse of t. So x of t and h of t convolved with h inverse of t. See, this entire product h of t convolved with h inverse of t should become 1. Only then multiplication with x of t will generate x of t. So 1 is indicated by delta of t and not of u of t. Why? Because delta of t exists only when t is very nearly equal to 0. Remaining part is 0. Convolution of any function with delta of t will be same function. So x of t convolved with delta of t will become x of t only. So remember the process of recovering x of t from y of t. I have given y of t to you, but I want x of t, given the h of t. So if you do this process, that is known as the deconvolution. Okay, recollect carefully. What is convolution? Y of t is equal to x of t convolved with h of t. If I give the input x of t, if you know the impulse response, you are going to get the output. Now I will do exactly reverse process. I will give you y of t. I will give you system response h of t, but I want to know what is x of t. That is known as deconvolution. Okay. Now, have you understood all these properties? Any doubt?
Yes, sir.
Now, I'll take certain simple problems which will illustrate and test for these properties. Find whether the following systems are stable, memoryless, and causal. Let us take the first example, e power minus 2 mod of t. So, t, you see here, it is mod of t. So, when t is less than 0, mod of t gets replaced by minus t. Okay, when t is more than 0, mod of t gets replaced by minus t. Sorry, t. Mod of t gets replaced by plus t when t is more than 0, and mod of t gets replaced by minus t when t is less than 0. Okay. Once you do this one, this system exists from minus infinity to plus infinity. Okay, so all range of t is varying from minus infinity to plus infinity, you are existing. So let us take h of tau. H of tau is equal to tau when tau is less than 0. So h of tau is not 0 when tau is not equal to 0. For example, tau equal to 1 you give. If when you give 1, it will become e power 2 tau. Okay, when you give minus 1, it becomes e power minus 2 tau. So it is the h of tau is existing when t is not equal to 0. When therefore the system is having memory. The system has memory, so it remembers the past. Now, when t is less than 0, let us say h of tau is equal to e power 2 tau, and you have the value. That is, when you give minus 1, it is e power minus 2. When I give minus 2, it will become e power minus 4. So even the value is very less, h of tau is existing. Therefore, system is non-causal system. Because system has a finite value when t is less than 0, system is said to be non-causal. Any doubt? Any doubt regarding this one? Okay. Now, look at the stability. What we said, minus infinity to plus infinity h of tau d tau, that is impulse response must be absolutely summable. Therefore, I'll split this integral into two parts, minus infinity to plus infinity in e power minus 2 tau, that is minus infinity to 0, it is e power 2 tau, this definition, plus 0 to infinity e power minus 2 tau. Just a minute. Hello. Now, minus infinity to 0 e power 2 tau d tau plus 0 to infinity e power minus 2 tau d tau. This I am integrating. So e power 2 tau will get integrated to e power 2 tau by 2 from 0 to minus infinity plus e power minus 2 tau by minus tau when 0 to infinity. What happens when you substitute this one 0, you'll get 1 by 2. For when you substitute minus infinity, you'll get 0. Similarly, for infinity, you'll get 0. For 0, you'll get minus 1 by 2. Minus of minus 1 by 2. So it will become 1. Therefore, it is less than infinity. So any value which is in, it can be larger value, but it should be less than infinity. Then the system is said to be a stable system. So we have tested the system for all the three properties. Any doubt till now?
No, sir.
Okay. Now let us take a similar problem, t e power minus t into x of t. Now, once again, it is x of t, not u of t. So, system has a value below 0 also. When I give minus 1, what happens? Minus 1 into e power plus 1 into x of minus 1. We don't know what is the value of x of minus 1. So, we assume that it is existing. So, when h of tau is not equal to 0, when tau is not equal to 0, it is minus 1 e power tau into x of minus 1. Therefore, system has memory. System is not memoryless. Now, when t is less than 0, you have certain value, that is minus 1 into e power 1 into x of minus 1, so on and so forth. If you give any value, you have certain non-zero value. Therefore, system is non-causal. So any system which has finite value when tau is less than 0, then you call the system as non-causal. Now, let us go to integration. When you integrate first function into integral of this one, minus infinity to this minus infinity to infinity, e power minus tau into tau, d tau we will do. So first function into integral of this one, e power minus tau by minus 1 plus e power minus tau into derivative of tau, that is 1. In both the functions, you'll get e power minus tau. E power minus tau generates e power infinity when the limit is minus infinity. So e power infinity will become equal to infinity. So therefore the system is unstable. The system is unstable. So even for one value, the output is infinity, system is said to be unstable. Okay, this you have to test for. That's why we have tested for minus infinity to plus infinity. Now, once again, let us take h of n equal to a power n into u of n plus 2. Once again, when you give, let us say minus 2. When you give, let us say minus 2, what happens? U of minus 2 plus 2, that is u of 0. U of 0 is 1. A power minus 2 into 1. Therefore, h of minus 2 is a finite value. When h of minus 2 is a finite value, therefore, a system has memory. H of k is not equal to 0 when k is not equal to 0. That is, for example, h of plus 2, I'll take h of plus 2 is a power 2 into u of 4. U of 4 is existing. Therefore, u of 4 is also existing. U of minus 2 is also existing. Therefore, h of k is not equal to 0 when k is not equal to 0. So, any value k equal to 1, k equal to 2, k equal to 3, any value you are giving, you have the value. It is a finite value. It exists both sides of 0. Then it is not memoryless system. Therefore, it is having memory. Next, h of k, as we know, that is not equal to 0 when k is less than 0. When you give minus 1, u of minus 1 plus 2, u of 1 into a power minus 1. So 1 by a into u of 1. U of 1 is existing. Therefore, system is non-causal system. So test for k is equal to 1 and minus 1. So if both the values are existing, then or at least one of them is existing. If h of 1 is existing or h of minus 1 is existing, then you say that system is not memoryless. That is, system has a memory. If let us say, if it is, let us say a power into u of n, then if any value, let us say a power into delta of n, then delta of n doesn't exist for n is not equal to 0. Then you say that system has no memory. So any values other than delta of n, you are going to get the memory. Now let us take the test for stability. So summation from k, so u of n plus 2 starts from n equal to minus 2. Therefore, we are taken the lower limit as minus 2, and where up to what it is existing? Up to infinity. Therefore, upper limit is plus infinity. So lower limit why it is minus 2 is the u of n plus 2 starts from n equal to minus 2. Therefore, h of k, I taken k equal to minus 2 to infinity, h of k, that's equal to minus 2 to infinity. H of k is nothing but a power k. So what happens? K equal to, let's say, if I take k, what is the answer? A power 1 by 1 minus a into 1 by a power minus of minus 2. That is 1 by a square. So this value is less than infinity. Assume that a is not equal to 0. If a equal to 0, then it will become infinity. As long as a is not equal to 0, this value will be a finite value. Any value it may matter. Therefore, system is stable only when 0 is less than a, less than 1. Why we put this condition? If let us say a is equal to 2. If a is equal to 2, 2 power 0 plus 2 power 1 plus 2 power 2 plus 2 power 3 will become infinity when k becomes infinity. Therefore, this summation will converge only when a is strictly less than 1 and strictly more than 0. Okay. So only at certain circumstances, that is between 0 to 1, this summation will converge and the system will become stable. These are the limitations you have to put when you write the answer. Any doubt here? Are you able to follow?
Sir.
Okay. Now you take this example, e power minus n into cos of n into u of n. Whether system has memory or not having memory. Whether system has a finite value when n equal to 1. System has a finite value when n is given 1. It is e power minus 1 cos of 1 into u of 1. Yes, it is existing. Once it is existing, then you can conclude that system is not memoryless and system is having the memory. Whether system is causal or non-causal system. Anybody? System is causal or non-causal? Anybody? See here. This summation will not exist when n is less than 0 because u of minus 1 will become 0. Therefore, this h of n will exist only when n is above 0. Therefore, h of k is e power minus k cos of k into u of k will exist only when k is above 0. Therefore, this system is a causal system. Once again, we'll add the summation from k equal to 0 to infinity. Why I are not taken from minus infinity is because of the factor u of n. U of n will exist only between 0 to infinity. Therefore, I started with 0 and end at infinity, e power minus k into cos of k. So maximum what cos can generate is maximum either plus 1 or maximum minus 1. So assuming that cos of k is constant, what happens? It is summation of e power minus k. So that will become 1 by 1 minus e power minus 1. That is 1 by 1 minus a. Maximum value which can be generated by the function is, assuming all the cases cos of k is equal to 1, is this much only. 1 by 1 minus e power minus 1, which is less than infinity. Therefore, the system is stable. Is it clear to you? So like this, for these three properties, you have to test it. Are you able to follow? Any doubt regarding the testing of impulse response? Any doubt? Shall I proceed further?
Yes, sir.
Now is a new topic, that is step response of LTI system. It is nothing but the convolution only with slight difference. Consider an LTI system characterized by its impulse response h of n. Now I am giving x of n, that is giving it to system h of n, and I am going to obtain y of n. What is the meaning of step response? Step response of the system is a response of the system when the input is a step, that is u of n. So whenever I ask you the step response, automatically you have to understand x of n equal to u of n. That will not be given to you. So I'll give h of n, input is known to you, u of n. I'm asking you what is y of n. Y of n is replaced by s of n, where s indicates step response. The step response is given by u of n, that is input u of n convolved with h of n, or h of n convolved with u of n. So what I will write? Summation for all values of k equal to minus infinity to plus infinity, h of k into u of n minus k. Let us see what is u of n minus k. U of n minus k is equal to 1 when n minus k is more than or equal to 0, or just is equal to 0. When n minus k is equal to 0 means k should be less than or equal to n. If k goes above n, for example, n is 5 and k is equal to 6, what happens? U of 5 minus 6, u of minus 1, that will not exist and it will become 0. Therefore, maximum value of k can become n. Therefore, I'll write my summation as s of n is equal to summation lower limit will become minus infinity, because u of n plus 1, n plus 2, n plus 3, all of them will exist. Therefore, k will become minus infinity, and upper limit is k is equal to n only. Therefore, k is equal to n h of k. So, s of n is nothing but the summation of impulse response. What is the meaning of step response? It is the summation of impulse responses. Okay. So, for the same way, I told you the discrete time system. For the CT systems, s of tau is given by integral from minus infinity to tau, h of tau d tau. K gets replaced by tau, okay, and n gets okay, h of tau into d tau, and the summation integral limits will be from minus infinity to tau. That's all. So let us solve the step response problem. Let us have h of n equal to 1 by 2 power n u of n. I want to know what is s of n. Once again, I'll directly start with summation from k equal to minus infinity to n, 1 by 2 power k into u of k. So obtain h of k. So what is this one? What is the value inside the summation is h of k. Wherever n is there, replace by k and write inside the summation. That is minus infinity to n, 1 by 2 power k u of k. Now, where u of k will exist? U of k will exist only from k equal to 0. Below k is equal to 0, u of k will become 0. Therefore, now I'll modify this summation as k is equal to 0 to n. Look at this one. From minus infinity, I modified k equal to 0 and upper limit I made it equal to 1, 1 by 2 power k. So what is the answer? So a power n summation for all k equal to 0 to n, a power k is equal to a power n plus 1 minus 1 divided by a minus 1. That is 1 by 2 raised to n plus 1 upper limit plus 1 minus 1 by 1 by 2 minus 1. So what happens? So 1 minus 1 by 2 raised to n plus 1 by 1 minus 1 by 2 if you take minus n outside. So the 1 by 2 in the denominator comes to the numerator. So it will become 2 into 1 by 2 raised to n plus 1. That is 2 into 1 by 2 gets cancelled. So I have 1 by 2 power n minus 2. Therefore, I have 2 minus 1 by 2 power n. N is more than or equal to 0. This itself is your step response. Okay, there is no need to write u of n every time. You can directly write as n is more than or equal to 0. Okay, look here. Any doubt? I'm going to re-explain.
Sir,
any doubt?
how did you get 1 by 2 whole power n plus 1 minus 1?
Here, this is sum to n terms of a GP. Sum to n terms of a GP, a power k is given by a power upper limit plus 1. What is the upper limit? N. N plus 1
N.
minus 1 divided by a minus 1. What is a here? A is 1 by 2. This is
1 by 2.
I have used the sum to n terms of a GP. That's all. This is what you have done in Z transformer, no? Same Z transform formula I'm using. It is summation.
Yes, sir.
Summation a power k is a power n plus 1 minus 1 by a minus 1, where a is distant 1 by 2 and n is the upper limit of the summation. That's all I'm doing. Okay.
Yes, sir.
Okay. Now I'll go to the next problem. Look here. H of n are taken as delta of n plus delta of n minus 1. So once again, I'll use the same formula. S of n equal to summation from k equal to minus infinity to n h of k. Now, what happens here? When n is less than 0, when n is less than 0, n equal to minus 1. What is the delta of n? Delta of minus 1 is 0. Delta of minus 2 is equal to 0. Therefore, first case, when n is less than 0, S of n is strictly is equal to 0. Next, when you put S of n equal to 0, that is S of 0. When n equal to 0, you put what is the value? Delta of 0 plus delta of minus 1. Delta of minus 1 does not exist. Delta of 0 is equal to 1. That is S of n is equal to S of 0 is equal to 0. Now, when n equal to 1, what happens? Delta of 1, when n equal to 1, it will become h of 0 plus h of 1 because it is sum. H of 0 plus h of 1 plus h of 2 plus h of 3 you have. So h of 0 is nothing but 1. H of minus 1 and all other terms will become 0. So I told when n equal to 1, it will become h of 0 plus h of 1 only. What is your h of 0? H of 0 is 1 plus h of 1 is equal to 1, because when you put 1 in this equation, what is going to happen? This will become 0 and this will become 1. So 1 plus 1 will become equal to 2. Okay, if you are confused what to write, you can write the summation from k equal to 0 to 1 only. So when you write k equal to 0 to 1, what happens? Delta of 0 plus delta of n minus 1. So put 0, so put 1 and put 2. You check whether the values are existing. If the values are existing, you write the summation. If the values are not existing, then you write it is 0. Okay, are you able to follow? Now, let us take h of t equal to t square into u of t. So I'll write s of t is equal to some integral from minus infinity to t h of tau d tau. So what happens? When t is less than 0, u of t is 0. Therefore, I'll modify the integral as 0 to t h of tau d tau. What is h of tau? Tau square into u of tau. U of tau becomes 1. Tau square u of tau d tau. So what is the integral of tau square? Tau cube by 3. When tau is equal to t, this will generate t cube by 3. Any doubt in this problem?
Yes, sir.
Now, Let us take h of n equal to 1 by 3 into summation k is equal to 0 to 2. Don't confuse this 3. This is the answer of previous problem. H of n equal to 1 by 3 into k equal to 0 to 2 delta of n minus k. So what is given? First you expand the problem. 1 by 3 into give n k equal to 0. This will become delta of n. Give k equal to 1. Delta of n minus 1 plus give k equal to 2. That will become delta of n minus 2. So h of n is equal to 1 by 3 into delta of n plus delta of n minus 1 plus delta of n minus 2. S of n equal to h of n convolved with u of n. So write delta of n plus delta of n minus 1 plus delta of n minus 2 whole divided by 3 into u of n. So what happens? Remember, any function with convolved with delta of n minus k. So for example, f of n convolved with delta of n minus k is equal to f of n minus k. That is, u of n convolved with delta of n will become u of n. U of n convolved with delta of n minus 1 will become u of n minus 1. Okay, plus u of n convolved with delta of n minus 2 will become u of n minus 2. That's all. So there is no need to convolve. So directly replace n by n minus 2, and if you are convolving here, replace n by n minus 1 and replace n by n in this equation. So this is your answer. What happens? Let us speak if n is less than 0. What happens? All of them will generate 0 because they do not exist. Therefore, output is 0 when n is less than 0. When n becomes 1, when n becomes 1, second term and third term will become 0. They do not exist. This will become u of 1 will become 1 by 3 when n is equal to 0. When n becomes equal to 1, what happens? U of 1 is existing 1 and u of 0 is existing, that is 1, but u of minus 1 will not exist. Therefore, 1 plus 1 will become equal to 2 by 3. When n becomes equal to 3, n is more than or equal to 2. When n is equal to 2, this one will generate 1, this one will generate 1, and this one will generate 1. 1 plus 1 plus 1, 3. 3 by 3 is equal to 1. For any value above 2, you give 3, 4, 5, any value, all the 3 will exist and produce 1. So answer will become equal to 1. Are you able to follow this problem?
Yes, sir.
Okay. We'll take one more problem. Find the step response for LTI systems. Same procedure. H of n equal to u of n. Summation n equal to minus infinity to n. H of n. So u of n does not exist when below 0. Therefore, I'll replace minus infinity by 0. X of n equal to 0 to n. U of n. U of n is 1. So addition of 1, 1, 1 plus 1 plus 1 plus 1, so on up to n. So total answer will become n and plus 1 value because n is equal to 0. Okay, so totally it is 1 to n will become n plus one more additional value at n equal to 0. Therefore, it will become n plus 1 because u of n is 1 only. So you are adding 1 n plus 1 times. Therefore, you will get the value of n plus 1. Okay. Now h of t is equal to, let us say, e power minus mod of t. Already you have done this one. When t is less than 0, it will become plus t. When t is more than 0, it will become minus t. So we'll integrate from minus infinity to t. So this is from minus infinity to 0. We'll take e power tau d tau, the first definition, and 0 to t I'll take e power minus tau d tau. Once I take this one, I'll integrate e power tau only from 0 to minus infinity and e power minus tau minus of e power minus tau from 0 to t. So I'll get 1 minus e power minus t plus 1 because it is e power minus t, the second function. When it gives 0, it will become minus 1. So minus of minus 1 will become plus 1. Total answer will become 2 minus e power minus t. Are you able to understand this problem? It is only one formula you need to remember. That's all. You put the value within the formula and just integrate. That's all. Any doubt?
Yes.
Able to follow?
Yes, sir.
Okay. So I'll stop the class now. I'll take the attendance. Don't go anywhere. Stay here. Okay, so if you have any doubt, you send me by mail. So I'll stop the class now. Okay, I'll send the notes through the class. So any doubt, I'll be able to answer your questions. Okay.
Yes, sir. Thank you, sir.
Okay. End the meeting now. Goodbye.
Bye, sir.
Bye. Bye. Bye.